Okay. Let's see. It's recording now. Okay. So let me be sure that it is. So the idea of this project is going to be, we have this code train model, right? This train model, what it does is going to basically, it gets one input. All it requires is one input. And that input is the timestamp. What time of the day is today? Okay. And why do I add that? Is just because I want to be sure that GitHub, when the git action runs, from beginning to the end of the git action, if I every time want to say get the current timestamp will change, right? So what I do at the beginning of the git action, I get the current timestamp and I pass it to every part of the code. This is the same timestamp, right? So this all it requires, it will get a timestamp as an input. Okay. The rest of the work, I'm just going to quickly go over it, is that every time this model train basically code will be called, what it does simply creates some synthetic data using using scikit-learn. I'm just calling to this function and says that, hey, give me 2000 data points, something between 0 to 2000, and that's it. I just create some fake data, right? And then I will check, do I have a folder for data in my folder structure here? So do I have data? No, there is no data, right? So what it does basically, if the data exists, it will save the data there and save the target, because it's two files, right? You see X and Y. If data folder doesn't exist, first create the folder and then do that. So far, clear? Yeah. So the next thing is that I will use MLflow, and for the moment, just get some idea of MLflow, because next lab we will dig into MLflow. Okay. MLflow is is experiment tracking software. You use it to track the steps of your model and future, the hyperparameters and everything. So I create basically MLflow set tracking URI. I want to save the tracking information in that folder. Okay. And then I give it a data set name. Basically, I create a time. What's the time now? So you see, this parts are just random mode. It's nothing about model. I just create some features. What's the experiment name? What's the experiment like? So for MLflow, because it's experimental tracking, right? So the experiment itself has a name, and also it requires an ID. Like I call it name. Like for example, let's say you're working on a project which is for patient heart failure detection. So I call the project name, experiment name, patient heart failure detection. And project ID, basically, it's you pass the experiment name, and MLflow itself creates an ID, unique ID, so it's able to query against. Right? So you don't create that. MLflow will create an experiment ID. Now, all you need to do is, again, we will learn this MLflow in details. You will say with MLflow start run. So what you want to do is that you want to wrap MLflow and put every part of your code inside it as all part of your training. That's why I will say with MLflow start run, what is the experiment ID? What's the run number, run name? And then I start everything within that. That's what MLflow does. It just monitors everything happens inside here. Okay. So I define some parameters that I want to monitor for. I create a dictionary and I say that these are the parameters that every time I want to monitor for. And I say MLflow log parameters. It needs a dictionary. It will log it for you. Then I create a random forest model, and I feed the data to it, and I make a prediction, and I say MLflow log the metrics of that model. Is that clear so far? Right. So then I will go next line, and I say that if there is a folder for models, if there is no folder to save the model, create the folder. Otherwise, I create a model version because I want to version the model. And that version comes from the timestamp that I passed at the beginning as an input to this code. And I create a version for that model, and I save the model as a pickle or whatever. That's it. You see, this is the model training. It's like a code that every time that runs, follows this process, saves the model, and terminates. The next code is evaluate. So evaluate, it technically does the same thing. First, it gets the same timestamp. Because evaluate, every time your model is run, you want to evaluate. Was it good? Right? So it gets the same timestamp. After that, goes and tries to find that model. Does that model exist with a given timestamp? If yes, it will load the model. If no, it will throw an error. And then it will create a fake new test data, right? And test the model against that fake new test data. Yeah, basically does the model predict and gets the F1 score. Okay. And then it will save them the score of the test data in a folder called metrics. Okay. Does that make sense? So that's all the code that we have. Now we want to automate this. That's the part we want to learn here. Not the modeling part. So in the previous class, you saw that for git action, you need to have a folder on your GitHub called .github/workflows, right? So within that, we're going to start with a file. Actually, let's start with this one. So we want to create basically an action that every night at, I think this is at 12 midnight. Every night at 12 midnight, repeat the model retrain code and then the model evaluation. Okay. So in order to do so, when you create this git action, or which is a YAML file, first you need a name for the process. You give it a name. The second question is on. On means on what operation or action should this code run? When, basically. We say on a schedule. It will run on a given schedule. And then what is the schedule? Cron is the name of the library being used for the time, basically, process. This means basically 12 midnight at 0 time. Doesn't matter. So definitely, if you want to understand numbers, go on the Cron website and you will see what's a 9 p.m., what's a 8 p.m. It's something like that, right? That's not the point. So that's the on, when to run this pipeline. Now, the next part is, what are we running? You create jobs. Jobs are series of steps that you want this action, git workflow to follow. Okay, so we call it, this is a retraining basically job, retrain the model. It will run on latest basically Ubuntu. You know, you might have a code. Think about it. It runs on what type of machine? Actually, it's your job to decide based on where do you deploy your product. If your product is a Windows based, you should put Windows. If your product is Mac based, you should put Mac. This Ubuntu, or all three. If your product works on all of them, you put all three. That's also a way for you to test. Does every time I do the calibration, will my model work on every platform? Okay. Ubuntu, the latest update, basically. Then, what are the steps of this job? So there's a parameter called steps. Within the steps, you're going to say step 1, which you saw the first 2 in the previous class, right? There's a checkout, basically. These are pre-built, predefined GitHub basically actions. So it's I want to check out the code, basically use this action checkout version 2 or version 3, I think also exists. But normally just put version 2. The next one is that I need Python in order to be able to run this code. You set up a Python. In order to set up Python, you call to these actions, again, pre-built, set up Python version 2. This is not a Python 2, it's actually Python 3. but version 2 of that file. And it tells you that, okay, which Python version specifically do you want? I want Python version 3.9. We could have 3.10 or whatever you think is necessary for your code. Okay. Next. Okay. So first one was that I check out my code. I brought my code, check it out, and I have it in this environment. Next, I install Python because I need Python, right? What is next? I need to install every dependency that we need for this code. And something that we will learn in this class is that as a practice of MLOps practice, basically, every time you create a model, you need to create a dependencies list. What do you need to run my code? Simple example of it is that we create this .requirement text file, and you put name of every library that is required to run this code. So, right here. Next is that before doing anything, you need to install those dependencies. How do we install those? Pip install -r requirement.txt. We'll install every libraries within that file. Okay. Next. Now, what did we need to run all those codes? A timestamp, remember, as an input. So next is that this part is not necessary. It's just based on the code that I have here. Okay. So I will create a timestamp and I save it. So timestamp, I get the current timestamp and I write it into this file, echo it into this timestamp.txt so I can store it temporarily. Okay. And then I give it an ID and I call it this is timestamp. So I give it a name and I run this code. This code is a Linux code, basically, because that's what we see here. That's also, to be honest, a reality. If when you go toward ML, you need to get comfortable with this bash type of or command lines, you know. So
is the implementation Ansible?
What was that?
Is it similar to Ansible?
It is, but how much I really don't know because I personally haven't worked with that much. But I think there are some overlaps. Right? How much I really don't know. So we run this. We echo means to write this in this, and we give it an ID. Okay, so now I have the timestamp, right? Now I can go run my codes, model training first, and then model validation. So I go here. Actually, so this part of the code that you see, file permission, I added to brute force GitHub because GitHub was giving me lots of problem with permission on this file to edit the files or to run the files because I have problems. So what I do for this train model, I check the permission and then I give it a new permission. Now I give it a read and write permission. It's because it doesn't run as a sudo. That means it doesn't run as an admin. So you might have permission issues. So if you have something like that happen, you can run this. If it doesn't happen, you don't need this. So this is what it does. One of them, it checks the permission. The other one assigns a permission, read or write, basically to a file. Okay. So now here, retrain the model. What to run? First, I call back to that timestamp.txt, that file, and I say, give me the timestamp that you're storing. So I get the timestamp, save it into a variable, right? Then I run Python, this file, and I pass the timestamp to it. Train model. This will run the train model based on the timestamp, train a new model, and saves that model into that models folder. Okay. Now I want to evaluate it. I create a new job, new task, evaluate the model, and I will run. First thing again, get the timestamp because you need to load the model using that timestamp. And these codes are separate from each other. Remember, every time you do a run, previously we got a timestamp. This one doesn't see that. That's why every time I need to get the timestamp again. So then I run this Python, evaluate that. Then I will create a metric for the for the file because so what I wanted to do was that the model creates a metric, but I want to change the metric name basically to be same version of the model. Model was a timestamp version. So that's why I created a file name, timestamp underline metric.json. And I basically move the metric file to this location and save it under this name. Right? Because remember, when you run the evaluation, it creates a metric. Right? It creates it. If you look at the code, right, it creates this JSON file metric, and it dumps it in the current running environment. What is the current running environment? Is here. Is here. This blue is the current running environment. So the metric lives in that. What I want to do is to pick that metric and save it into this folder so I can access it outside of that. That's what happened. And I give it a new name, basically. So now I have this one continuous on error. That means what if happened if your model pipeline had an error? Should I repeat? If we say yes, then it will, you need to define also how many times, how often you want to do. For this task, I just say false. Don't continue if there's an error is happening. The next thing is that store the version, the new model. So I basically pick this model and I bring that model, also move it to this GitHub workspace. So I want to put everything that I ran here, I want to store it into my GitHub workspace, basically, because otherwise they don't exist. Their life is short. So store the version of the model. And the last thing is that, okay, we developed the model. I want to commit and push this to basically to my repo, right? So in order to do so, you can create a code for commit and push on GitHub. You will run. First, you need to config, obviously config that this is my user email, this is my username, right? And I want to, what do you do for GitHub? Git add, git commit, git push, right? So I would say git add, what to add? The metric and the new file, new model. Add these two, and then commit it, right? And then push it. Same thing, right? And it says on what environment you're doing this. It requires a password because I say username and password, username and ID. What's the password? Because I'm in my same environment, I'm not outside. So I don't need to enter the password for security. I just say that the token that you can use for validation is secret.github token because you're in the same environment. So no one can seize that basically. It uses the current token because it's in your repo, right? So when you have this, all of that, that's what you have. And you basically here on the labs, GitHub labs, let's see. I don't think I have an action for that because yeah, this is a full repo. You basically create a new workflow, and as part of new so when you have it in your own folder, when the .yaml exists in that GitHub.workflows, GitHub by default picks it as an action. Okay, and what will happen here is that every night at 12, this two code basically this will run execute. And if there is an error, it will provide you an error. Hey, the code sends you an email. The action didn't go through. Otherwise, it basically says action no response. So this action file, it's automation of model retraining on specific certain time and validating. There are more you can add to it. So just everything you want, you can add, create a different modules basically, and run the code in order that you want to do that. The second, this is the last part, sorry. There's another version that says, what if you don't want it to do it on time, and you want to actually update and calibrate the model every time there is a code change? So in this one, the only thing is going to change is on I would say on push, if there is any code, new code that comes to the main branch, if there is a push to branch main, it could be any other branch that you want, run the pipeline. That means if there was any code change to the main branch, rerun the model, create a new model. Right? That's the version. And again, there are ways that you can change this. I want you to think ahead of time. The goal for you would be to go pick this lab. Okay, run it on your environment. Two ways. It's free. You have a GitHub, it's free, right? Be sure that you have both Git Action and as part of your basically, if you go to GitHub workflows, Git Actions, both YAML is activated. One of them, the one on push, as soon as you push your code, it should run. And the other one, check it every midnight, like for 1 or 2 nights. It's free again. Be sure that it runs. There's no error coming out of it. Okay, so that will be basically your homework for lab homework. Is this clear? Sorry, I went through it fast. I lost the track of time, but I will try to next class to basically do this slower. Yes. It happens in GitHub. So keep this in mind. GitHub cannot run large models here. But if you have a large data and stuff like that, you need to work with Git large file system. Git LFS, large file system. Yeah, Git LFS. So there is a normal GitHub that you use, which is for a smaller size file, a smaller data. As soon as you want to go to a larger data, you need to use Git LFS. I think that's also free, Git LFS. But if